For the second year OGC Interoperable Simulation and Gaming Sprint, Ecere focused efforts on improving visualization and streaming of 3D geospatial content. One of the tasks was improving the generation of 3D tilesets in its Gnosis map server. A major improvement was generating 3D tiles for data at lower resolution and associating a correct geometric error to each level. This enabled visualization clients such as the Cesium.js library to perform better while loading data for a larger geographic area. Models further away can be presented at low resolution, while those closer to the camera can be displayed at full resolution, or the number of visible models can be adjusted. Ecere also improved its 3D Tiles client to better handle tile sets generated using different approaches, such as where transforms are specified. In the 2020 3D CDBX Tech Sprint, investigating a next version of the OGC CDB standard, Ecere contributed to prototyping a data store for it based on OGC GeoPackages and extensions. In this year's ISG Sprint, Ecere aimed to visualize the CDBX data store prototype of the San Diego dataset and provide distributions sourced directly from it. A key aspect of the proposed CDBX GeoPackage store is a configurable and deterministic system to partition very large datasets, such as global data at high resolution, into multiple GeoPackages, allowing to balance the number of files with the size of each file. In one configuration, a single GeoPackage may contain the entire CDB content for a small area, making it easy to preload on mobile devices. The content could be split into multiple GeoPackages based on geographic location, still regrouping multiple data tiles within the same extent. During the sprint, Ecere implemented the capability to present a CDBX GeoPackage data store as a single data source with nested data layers, each representing components such as terrain elevation, satellite imagery, or 3D models. A second important aspect of the proposed CDBX GeoPackage store is an extension for storing 3D models inside GeoPackages. Those models may be stored in a shared table and instantiated at multiple geographic locations, or batched so that all 3D models within the tile are stored in one database blob. In previous OGC initiatives, including last year's ISG Sprint, Ecere prototyped and demonstrated a simple approach to deliver 3D content by extending the OGC API tile specifications. In this year's sprint, Ecere further improved support for this approach in both its Gnosis map server and its Gnosis cartographer visualization client. Ecere also developed a new informative annex for the 2D tile matrix set standard, extending its capabilities to support additional dimensions such as 3D content. The extensions support both points vector tiles referencing and instancing shared models, as well as batched 3D models as a tile's payload. In either case, different formats such as GLTF, 3D tiles batched 3D models, or Ecere's compact E3D model format can be supported. In collaboration with Steinbeis, Ecere initiated work towards demonstrating the visualization of integrated indoor and outdoor geospatial data. Ecere's Gnosis SDK supports visualization of data from a global scale to local scale at high resolution, such as for augmented reality indoor scenarios. Experiments focused on visualization of a 3D model of an HFT Stuttgart building integrated within data from its surrounding geographic area, such as buildings sourced from OpenStreetMap data. In this case, interoperability was achieved by exporting data from SketchUp as Collada. Other attempts were made through GLTF exports, and Ecere contributed to the Open Asset Import Library's GLTF2 module as part of the sprint. Improving and demonstrating support for virtual and augmented reality is also the subject of ongoing and future development work in Ecere's Gnosis SDK.